Physics, Part 63. Newton's law of gravitation, we can see it in the chapter 11, tells us that all masses attract one another. We rely on the force of gravity to keep us on Earth. When two masses are pulled apart, work is done on them, and so they gain gravitational potential energy. If the masses move closer together, they lose gravitational potential energy. Changes in gravitational potential energy are of particular importance for an object near to Earth's surface, because we frequently do work raising masses, and conversely the energy stored is released when the mass is lowered again. An object of mass m near the Earth's surface has a weight mg, where g is the acceleration of free fall. This weight is the force with which the Earth attracts the mass, and the mass attracts the Earth. If the mass moves a vertical distance, delta h, work done is equal to force into distance moved, mg delta h. The cars on the roller coasters have stored gravitational potential energy, and when they move, they in fact move on the potential energy, and this is what they have because of their position. And of course they are attracted by the gravitational pull. When the mass is raised, the work is done, the work is stored as gravitational potential energy, and this energy can be recovered when the mass falls. Change in gravitational potential energy is delta EP is equal to mg delta h. I beg your pardon, please. It is important to remember that for the energy to be measured in joules, the mass m must be in kilograms, the acceleration g in meters, meter per seconds, and the change in height, delta h in meters. Notice that a 0 point of gravitational potential energy has not been stated. We are concerned with the changes in potential energy when a mass rises or falls. We've got an example for you. A shop assistant stacks a shelf with 25 tins beans, each of mass 460 gram. Each tin has to be raised through a distance of 1.8 meter. Calculate the gravitational potential energy gained by the tins of beans, given that the acceleration of free fall is 9.8 meter per second. Total mass raised is 25 into 460, which is equal to 11,500 gram, 11.5 kilogram. Increase in potential energy is mass into gravity into delta h. 11.5 into 9.81 into 1.8 is equal to 200 joules. Now it's your turn. The acceleration of free fall is 9.8 meter per second. Calculate the change in the gravitational energy when a person of mass 70 kilogram climbs a cliff of height 19 meter. B, a book of mass 940 gram is raised vertically through a distance of 130 centimeter. C, an aircraft total mass 2.5 into 10 power raised to 5 kilogram descends by 980 meter. Kinetic energy. An object falls, it loses gravitational potential energy, and in doing so, it speeds up. Energy is associated with moving object. In fact, we know that a moving object can be made to work as it slows down.